services supporting regional sales, manufacturing and operational teams in the consistent delivery of quality products and service excellence. In his role, Eden connects research and innovation and marketing teams with technology partners and global customers to identify and develop opportunities to problem solve using innovation. Karl is a qualified manager, engineering geologist with over 17 years professional experience in both iron ore and metals. His experience encompasses strong technical and leadership attributes within the mining industry, working in mineral resource development, operational readiness, mine geology, near mine exploration, strategic mine planning, development, and optimization and execution. Today, they will be talking to us about ore body knowledge to blasting outcomes in tomorrow's mine today. Hill and Orica have been working in a close strategic partnership since 2017, aimed at delivering Hill's smart future pit port vision of creating tomorrow's mine today. This program leverages new technology and the application of innovative thinking to maximise efficiency to meet the needs of the future. So I'll hand it over to Eden and Karl. Thank you.
Thank you for that, Kate. Just if I can just confirm with you, I am sharing the screen. You can see that title.
Yes, we can see the design for outcome, Orica and Hill.
Fantastic. Thank you very much for that. Thank you very much for everyone attending today, for your time. It's after lunch, so obviously everyone's full of energy. We will, look, really happy to be here today to present with our partners, Hill. As you can see, Karl is actually up at site. I'm based here in Perth. We're going to tic-tac and give you a case study on a project that we've been working together on for the past couple of years. A beautiful title that was sculptured, which is Ore Body Knowledge to Blasting Outcomes in Tomorrow's Mine Today. It's quite a mouthful, so just to make it simpler for all in sundry, from here onwards, we're going to refer to this as Design for Outcome, or simply DFO. Okay, and it's an overview of how Orica and Hill have been working with ore body knowledge to optimize blasting and mining outcomes. So we will proceed. Karl, I might just pass over to you for a second. Just on mute there, mate.
Karl, we can't hear you. You might want to change your speaker setting. No.
Just while we
move over on the bottom left and next to the microphone icon, and once you click on it, there's an option of select microphone.
Can you hear me now?
No, we still cannot hear you.
No, I could hear him.
Yeah, we can.
Oh, can you hear me now, can you?
Yeah, that's good.
Excellent. Finally, thank you. Thank you for being patient. Thanks, Eden. I'd just like to take time just to say a few words. So Chris Erickson is our General Manager of Innovation and Technology, and the statement there is very clear in terms of what the expectation was for the Design for Outcome, and obviously building that as a vision essentially for the alignment between Orica and Hill with our innovation and technology roadmaps. So I'd like to take from there, it's quite straightforward in terms of where the next level is in terms of innovation for growth and success for Hill and Orica conjointly.
Thanks for that, Karl. I'll look, just before we get too far into the presentation, just a quick introduction on who Orica and Hill actually are. So Orica is the world's largest provider of commercial explosives and innovative blasting systems, while Hill is a high-performing iron ore company with a world-class integrated iron ore mining, rail and port operation right here in the Pilbara in WA. Together we share common goal, and that is harnessing innovative thinking and technology to deliver operational excellence and business priorities. Our partnership commenced back in late 2017, and since then we've been collaborating to create an innovation roadmap, which is filled with a number of enabling technologies, innovation initiatives, targeting enhanced safety, quality, efficiency, and profitability. We'll move into just talking about, well, the project itself. So design for outcome, how did it come about? Rather than me explain this, I'm actually going to pass over to Karl and ask him to give some background on how we sort of define those problems.
Yeah, so part of the discovering was purely for the design for outcome project. Was our first objective was to clearly establish what was the problem and what were we trying to solve and what were the unmet needs. The alignment for both Orica and Roy Hill's technology was essentially through aligning our innovation roadmaps. With this in mind, some of the key deliverables aligned to the innovation roadmaps included understanding the variability of dig performance solely from a mining operations perspective. But outside of this, there were some other dependencies which we obviously wanted to really identify and understand better across a large scale operation. And that's really around identifying investment around blast performance, and the variability is a result of a high cost in the rework that is likely to occur due to not clearly understanding the nature of the ore body in particular, and also the complexities around devising a functional mine plan and really building functionality around how that can translate through into an active mining operation. So that's for the solutions, essentially. The Roy Hill data was really around integration. How do we build an enterprise platform through using streams such as data science, algorithms and machine learnings, where we could actually really unlock the value within the data that was available to us, and really understanding the blast design and how to optimize that for the targeted outcome as part of the project. Overall, it's about reducing blast variability, which obviously really symbolizes the value in our product, which we sell to market, and also really encapsulating where we can identify reducing our mining costs as well. So overall, having that alignment between Roy Hill and Orica has been exceptionally rewarding, more or less around the enterprise and the architecture and integration.
Thanks for that, Karl. Look, just a little bit around the solution we actually designed together. There were many considerations. You can see some of those listed here. Look, the solution or set of solutions needed to fit, first of all, within Roy Hill's smart mine imperatives. So Roy Hill is looking to fast track its way to a smart mine of the future. And Orica was, as Karl has mentioned, Orica was aligned to helping them realise that vision. We focused on how to accelerate that journey, what technology and capabilities are already available in the market that we could bring in and deploy to help accelerate that journey, but also where there are gaps that needed to be filled. We wanted to maximise the effectiveness of the solution or set of solutions that we designed and developed. So both companies were investing a lot of time and resource in solving the problem. So we're eager to make sure that we see return on that level of investment. Roy Hill is a very large, for those of you not familiar, they're a very large mining operation. Therefore, the solution needed to be scalable and deployed in a way that we minimise any disruption on their mining operations. They're a single mine operation, so it was imperative that as we were deploying, we were able to supplement current operations and enhance or enrich the value that they're extracting today. For Orica, it's imperative that as we develop a set of solutions, that it was portable. So part of our journey with Roy Hill was helping to create something that we could pick up and take elsewhere to other mining operations globally, and see if we could enjoy the same type of value returns for other customers as well. Just a little bit about the solution itself. Karl, I'll get you to walk through. This is for many of you who've been through the earlier workshops with Nick Beaton and Angelo Labriola. You may have seen this slide, but Karl, in your words, I'll get you to explain a bit about what the deployed solution actually does.
Yeah, thanks, Eden. So in terms of deploying and really delving into the data warehouse, which was available to both Orica and Roy Hill, was really to unlock and really understand the ore body, really identifying the ore body knowledge in terms of energy matching explosives, in terms of optimizing the outcome, both in fragmentation, dilution, and also ore loss. And essentially from there, it's really about identifying the value within the data, and through a series of algorithms and data science has really been able to really open up and unlock that value and understand the complexity and the variation that's likely to occur within the ore body, but also along the transitional zones between the waste and our low-grade horizons as well. So what we have here is it's very simple process where the top image there is traditionally what would be estimated from the mine geologist as an example, and really giving a really one dimension, if anything, overview of the complexity that's likely to occur within the ore body. And then from there, we've been able to really unlock the measurement and understand the measurements derived from our measure well drilling data from our production drills, and really understand how we can actually develop a domaining system, which is driven by data, ensuring is that it's bringing to light the complexity and the detail in order to make the right decisions. And as you can see, as it flows through that process there, and the closed loop feedback situation is applying a lot of visual analysis and understanding for the drill and blast engineers to actually formulate an optimal design for loading of explosives. And then you can see, obviously, down to the optimized energy matching is really identifying where you can actually encapsulate that value from the explosives, which is supported and supplied through Orica.
Just before we move on, just a couple of points I wanted to raise with regards to this. First of all, Roy Hill already had a number of sensors deployed in the field today, like many mining operations. They have drilling rigs equipped with MWD sensors. So they were already collecting a lot of information. Part of the beauty of the solution that we've created here was actually how do we take the data that is being collected and use it in a way that's informing engineers or decision makers on how to optimize and streamline that continual improvement process. I think a question was raised during one of the earlier workshops with regards to the granularity on the type of data that we see. And the images that you see on the screen at the moment, we're showing you in a two-dimensional plane. However, obviously, the data that we're receiving from these MWD sensors gives us a very granular level. So we're using it down to around 30 centimeter intervals today. However, there's no reason, if we can't continue to tune these sensors, that we couldn't look at more complex types or slices on the data. What we wanted to do next was just to walk you through a bit of an example on how this actually works at Roy Hill today. So what you're seeing here are standardized drill designs. So the drills are designed by the drill and blast engineer. The drill patterns are designed by the drill and blast engineer. They're deployed to the autonomous drills that Roy Hill has operating in the field today. The MWD equipped drills capture geological hardness, and that data is communicated to that cloud-hosted enterprise platform that Karl had mentioned. Algorithms sitting on that platform then go to work on the MWD data, cleanse it and domain those transitions in the geological hardness throughout the drill hole and right across that drill pattern. And as you can see from that, the image that's produced or visualization that you can see on the screen, the MWD data is able to clearly identify different transitions in hardness to which algorithms can then apply the right levels of energy in order to deliver a target outcome. And in this instance, we're talking about a target degrade. Once those geological hardness domains are identified and the energy matching to those hardness domains are applied, on the cloud. Those are then pushed out to the explosives loading equipment, where in-field delivery of those loading rules is automated. So in the instance we have here, we've got MMUs that are equipped with a digital or load plus system, where the operators merely present at a hole and then press the start button. And all the manufacture of the product, the delivery to design specifications, including product type, deck length, etc., is controlled centrally to that design. The actual delivered parameters are available in real time, so progress can be tracked just to monitor quality and accuracy. And that information is also stored in the cloud, so it can be used in KPI and compliance reporting, but is also used for performance tracking and later in design optimization. Karl, I'll get you to walk through what happens from there.
Thanks, Eden. So in terms of performance tracking, it's relatively consistent across many operations, is whereby we use fleet management systems. Our fleet management systems can be interpreted through material inventory tracking, dig rate performance from excavators as an example. So it's a good feedback loop to really actually understand and analyze performance of the blast. So with really encapsulating the measure while drilling data through a series of algorithms, as Eden alluded to, we've been able to really ascertain and drive that back into the production fleet and really track the performance of a particular machine over a timeline, as you see in the illustration below, measured against the dig rate. And obviously we have target dig rates, which is optimal for dig performance, and really understanding in terms of where we can actually unlock and understand the data and better define our parameters, and also check and validate the algorithm and the machine learnings as well moving forward. So when we came to the decision, it came down to, well, what are the key metrics and how do we measure success, is what we referred to in Chris Erickson's statement at the start of the presentation. So data-driven decision-making. So we can always review a higher drill and blast cost and increase productivity. So we can actually increase our powder factors. Excellent. We can fragment the material to target dig rate, but therefore we can also diminish our value with regards to fragmenting a lump product, which is desirable in the iron ore industry. And we just have diminishing value there, but also what that does is increase the explosive costs essentially. Well, on the other end, we can lower the drill and blast costs by reducing powder factors and really taking extreme measures on birding and spacing of drill patterns. And what that does is decrease productivity. So we have large oversize can result as a consequence, and therefore impact digging rates and so on. But also removes value from actually being able to actually feed that downstream through a crushing circuit and further on down through the value chain. So the maximized value is obviously to find the sweet spot, and that sweet spot's determined and using the value within the data. So we're looking at a 10 to 15 million $10 to $15 million savings, but in the next 3 years, which is a target, which we've held ourselves accountable to sustain. And that's through decreased blasting, optimizing our powder factor ratios, optimizing the pattern expansion to decrease, obviously, drilling costs, and also sustain an optimal digging profile.
Thanks for that, Karl. Look, so that's a snapshot of the project that we've undertaken today under the title of Design for Outcome. So that specific outcome that we targeted there were actually two, as Karl has alluded to, is really focused on how do we pull the right levers to get the right balance between achieving a target productivity at the excavation point, but trying to minimize the cost of delivering that outcome as well. So tweaking powder factors, reducing our explosives consumption, reducing our drilling consumption to deliver the lowest cost per tonne out the gate. Now, as we move forward into the project, this project is now deployed at Roy Hill. We've been operating, as we say, we started the journey around about 2 or 3 years ago. We're now successfully deployed in the field. Our next point of focus, we're going to pivot and start looking at predictive drill design as one of those elements that we are working on today and trialing in different aspects. So it's really how do we automate the drilling design. So the last project was how do we automate the loading rules, so the generation of what explosives get placed into each holes and at what lengths. Now we're looking at how do we automate drilling design, so prior to the drills marching to the bench. And effectively what we're trying to do is codify the role of the drill and blast designer. So how do we take the best elements of what they would typically do and optimizing them and place these into an algorithm to automate the process. We're also looking, the next part of the journey is also to move away from a recommendation engine. So today we have a recommendation on how to apply. The decision is still down to the Roy Hill drill and blast engineers as to whether they want to apply the recommended loading rules. But what we want to move to next is to have more of an adaptive energy matrix. So this is where you're really starting to talk about how do you yield the best benefit from machine learning and this closed loop feedback loop. So training the energy matrix using data received initially from DIG, but then bringing in other measurement points further downstream, either through the crushing and comminution cycles, such as fragmentation or potentially power draw and crusher throughput, to really find the sweet spot on how do we yield or deliver the best result for Roy Hill. Some of the, in order to move further downstream in looking at outcome measurements, we're also going to have to look at developing new technologies to measure. So fragmentation is one of those key areas of focus today. There are a number of technologies that we are looking at in the market that we are trialing. There's limitations to those. So there is a bit of design and development required to optimize specifically for Roy Hill. And then further afield, we're looking at how do we integrate some of those elements from the comminution circuit. So power draw, how does that start to come into the design aspects to optimize the balance between fragmentation and also investment in energy. So a number of new developments that we're now focusing on with Roy Hill. As Karl alluded, look, the journey to date has been highly rewarding. We're starting to yield the benefit. Low numbers today. The next 3 years, we're looking at a $13 to $15 million payback. You know, if we don't deliver that, we'll be bitterly disappointed. We're hoping to reach for the stars and go beyond. But that is what we wanted to present to you today. Okay, we'll now pass it over to some questions.
Oh, thanks, Karl and Eden. Unfortunately, we don't have any time for questions. You used all your time up with the talk, so you've done well. There's one there in the chat if you want to address that afterwards. But I just wanted to say the visualizations in the presentation were really impressive, and I hope it helps communicate to more and more people. I was very impressed. Up next, we've got Dr. Jeffrey Batt from the Minerals Research Institute of Western Australia. Jeff delivers value to partners in the mining and resource sector through insightful analysis, strategic advice and management services across complex research programs. Currently a research portfolio manager for the Innovative Minerals Research Institute of Western Australia, his success in this role is built on a foundation of problem-solving professionalism and soft power management honed by 20 years as a respected research geologist, consultant and award-winning communicator. So Jeffrey's going to talk to us about research frontiers in real-time processing of massive digital data sets in mining. So let's see how that communication experience progresses to today's presentation. Thanks, Jeffrey.